Hello, everyone, and welcome to this free HydroComp webinar. My name is Adam. I'm a project engineer at HydroComp, and I'm going to run through a few examples in PropExpert. Today, we're going to be focusing on using prior trial to anchor our predictions to some sea trial data in order to improve our overall analysis. We'll use PropExpert to size a propeller for an existing vessel. On the screen, hopefully you can see some of the specifics about the vessel we're looking at. For those who are unfamiliar, HydroComp PropExpert is a tool created especially for the selection and analysis of propellers, particularly for workboats and pleasure craft applications. Today, we will see how existing performance data can be used to improve the analysis of a new propeller. We're going to run through the sizing, and then we're going to refine the sizing to accommodate the sea trial data. We'll also use PropExpert to evaluate the applicability of a new engine, gear, and propeller to improve the top speed in the second sizing. The vessel we will use today is a 14.5-meter twin-screw motor yacht. The engines are specified as a 202 horsepower diesel engine rated at 2,800 RPM, and they've already selected the reduction gear to be a 2.25 to 1. So what we're going to do is we're going to begin by entering this data into PropExpert in order to provide them with an initial propeller sizing for a 20 knots top speed. I'm going to minimize this image window here, and I'm going to pull up PropExpert. The first thing we'll do is start a new project. One of the very first things I like to do is set my units up. Immediately, I'm going to choose SI units, but I'm going to specify power and horsepower. Now I can enter in some information about the project in order to show this information in my database. Later I can go back and I'll know that, this was a 1.5-meter motor yacht. We give it a vessel name. We can add some notes, such as it's an initial propeller sizing. Of course, we can put our address here for the reports. We can move to the vessel page where we'll begin to enter information about this particular motor yacht. It's a planing vessel operating in salt water with 2 propellers. The maximum diameter given to us by the builder was 580 millimeters, so we'll enter that. The immersion is how deep the propeller is sitting to the shaft line. So we'll enter in 700 millimeters, which is the number that was specified by the builder. In general, if you don't know, it's very safe to enter in a propeller diameter. So we could put 580 there, but we'll use the actual number, 700 millimeters. We're going to enter in the length of our vessel, which is 14.5 meters overall. Enter in our weight, 12,000 kilograms. Our design speed is going to be 20 knots, and our cruise speed is about 3/4 of that, or 15 knots. We're going to use the average hull formula, and this multiplier is typically 0.9. That's the default value for PropExpert. That's the recommended value from HydroComp is 0.9. I just did a new installation, so it happened to be 1.0 here, but we'll continue on. We'll put in some information about the engine. We'll use a generic diesel curve. 202 horsepower at 2,800 RPM. And PropExpert will quickly estimate the shape of the power curve for us. Of course, we can always go in and refine our power curve by changing the points and entering an actual engine data, but it's really not needed for this particular project. So we'll set this back to estimated and use the estimated curve here. can proceed to the sizing page. The first thing that we can enter in that we know is the gear ratio. It's a 2.25 to 1. So we enter that in immediately. We'll size a Gone style propeller with 4 blades. Sorry about that. We'll size a Gone style propeller with 4 blades, and we'll initially run the sizing to size blade area, diameter, and pitch. We get an initial specification, and now we have to refine our specification based on what product models we have available. So we may not have a propeller with blade area of a BAR of 0.71. So we may have to refine this down to a 0.7. When we enter the value, PropExpert automatically sets to keep that size parameter. Just like the gear ratio, we're now locked in to 2 parameters, size for diameter and pitch. We build our sizing, and we get about 645 millimeters for pitch. This is going to give us 19.6 knots, and we can review the performance and cavitation by looking here. We see that cavitation is about 10%. That's on the edge of being acceptable, so we'll accept that. It would like a little more BAR, but unfortunately the 0.7 is what we have available for propellers, so that's what we're going to use. But the cavitation is acceptable, so overall we're happy with this sizing. Because we can't get a 640 pitch propeller, we'll actually change this to 645 millimeter pitch. We'll drop this down to 640, something that's a little more common. We build again, and we see that our final calculated max speed is going to be 19.4 knots, which is pretty close to the desired speed of 20. We can't really improve the speed much more beyond this without going to higher blade area or a different reduction gear ratio. So at this point, we would provide our recommendation to the manufacturer. Now, we're going to progress to the second sizing using the prior trial. I'm going to pull up a slide here that will discuss the equipment options that we have. So essentially, the case is that a few months later, the manufacturer returns to us for a new sizing on the same vessel. The 14.5 meter motor yacht was actually a bit heavier than we expected, and the actual speed during the sea trial with the original propellers was 19.2 knots. The engines only reached 2750 RPM, so they didn't reach rated RPM, and they didn't reach the expected speed. The actual vessel weight during the sea trial was 12,400 kilograms, and not the 12,000 kilograms that we used in the initial sizing. The owner of the vessel would now like to reach a desired speed of 26 knots, which is a substantial increase. Require a new engine, a new gear, and even a new propeller. The owner is trying to decide between the existing engine of 202 horsepower and a 275 horsepower engine rated at 2,400 RPM. The new engine is available with a 2.0 or a 2.25 reduction gear. The owner has also clarified the maximum diameter of the propeller is 610 millimeters and not 580. So they can actually swing a larger propeller. He would like to continue to use his existing propeller if he can. So he wants to know if we can use the existing 580 millimeter propeller and just repitch it to a new pitch, whether that's higher or lower depending on the gear ratio. So there's a lot of information, but let's begin by using the existing trial data to improve our prediction model. On the vessel page, we notice the average hull prediction formula. And let me pull that up here. The curve on the graph here is what we're talking about. This is the predicted power for the speed for the particular vessel. This is based off of what we call an average hull. Now, it's a statistical regression based on vessels of that size and weight. But any particular vessel may do better than average or worse than average. And so what we can do is using sea trial data, we can calibrate this multiplier in order to figure out how much better or worse this particular hull is than average. In order to do this, we're using the propeller model as kind of a dynamometer to calibrate and predict the drag. So we know that a propeller of this type spinning at this RPM produces this much thrust, and therefore we can kind of back calculate the drag from the sea trial data. In order to use prior trial data, we drop down the average hull drop-down list and we select prior trial. This is going to enable a button below that allows us to enter our speed prediction data. So we can put in the actual conditions that we saw on trial. We had 19.2 knots top speed. We reached 2750 RPM, and the weight of the vessel was actually 12,400 kilograms. So we enter those corrected values here. We're using the same engine model, 202 horsepower at 2,800 RPM. The gear ratio was 2.25. We have to enter in the specifics of our propeller model also. So we enter in the 0.70 blade area ratio, the 580 millimeter propeller diameter, and the 640 millimeter pitch that we specified. These factors should be the same as they were in the initial sizing. What we'll do is we'll build the trial prediction. And what we see is the thrust developed is 85% of the average hull, whereas before we were saying the vessel was characterized by a 0.9 multiplier. What we're finding is the multiplier is actually 0.85 based on the sea trial data. So what that means is that this hull is a little more, has a little less drag than the average hull formula initially predicted. It's actually 6 to 7% better than the original drag was being predicted. The power used, you see, is 93% of rated, which because we're not reaching RPM, the 2750 out of the 2800, we know we're hitting an overload case. We'd kind of expect power to be near 100%, which it is. But remember, there's not, this is percent of rated power, which is 202. There's not 202 horsepower available at 2750 RPM. And so this is likely why we're hitting the overload case, that at 2750 RPM, there is only 93% of the rated power available, and we're using all of that. We can accept this once we're happy. There's not a lot to play around with here. It's very straightforward. It just recalculates, and we'll see this number here is going to be moved over into our prior trial multiplier. So our multiplier dropped from 0.9 to 0.855. And let's just progress through the sizing and see how this affects it. If we build the sizing here, we see our trial condition, 2750, 187 horsepower being used, which is probably what's available at that RPM. And we see if we had been able to reach rated RPM, we would be hitting about 19.8 knots, which is higher than the 19.6 knots we originally predicted. That kind of correlates with this being 6 to 7% less drag. So now we can begin to evaluate the rest of the equipment for the subsequent propulsion sizing. Now that we've kind of better characterized our vessel, we can begin to see what it will take in order to make 26 knots. So let's go back to the vessel page here and let's update our speed. We enter 26 knots. Immediately we see an estimate for horsepower, 656 horsepower. This is kind of an indication early that maybe the expectations of the owner are a little optimistic. They want to put two 275 horsepower engines in here, which is not enough horsepower. It's not 656 horsepower. So we probably won't be able to make this 26 knots just with the installed power that they're giving us for options. So that's an initial indication that we may not be able to reach that speed. We're going to leave the original engine in here at first so that we can evaluate whether we can keep the original engine, the original gear, and maybe just repitch the propeller in order to achieve a higher speed. We go to our sizing, and we're going to want to keep the original propeller, the 580 millimeter diameter, and we're going to think about repitching this propeller. So we're going to size the pitch. Again, we're looking for 26 knots here. We're going to build this prediction and see what we get for a new pitch and a new top speed. So we see that if we can increase the pitch a little bit to 655, we're going to gain a little bit of speed. It looks like we'll reach about 20.2 knots just by repitching the propeller based on the new, after anchoring our prediction to the sea trial data. We can get a little more performance out of this boat if we just repitch the propeller. Let's also continue on, because repitching the propeller alone will not achieve the 26 knots that's desired. We need to continue evaluating some of the options here. So one of the other options was a new gear. We can actually use either a 2.25 or a 2.0. So let's change the gear ratio to a 2.0 and see how this affects our sizing. Again, we're going to size pitch because we want to see what, if we get a new gear ratio in there, what will the new pitch of the propeller be just from a repitch. So we'll build our sizing again. We see that the pitch of the propeller dropped to 556. It's generally not very easy to pitch down, so this isn't a very feasible option, but we see we're still very short on our 26 knot speed goal. We're using also, we can see at 20 knots, even with the 2.0 gear ratio, we're using all the available power. 202 horsepower is being used, 2,800 RPM is being hit. So it looks like we might need additional power to help us reach this 26 knot performance goal. And that's what we're going to evaluate now. So now we're going to look at a new engine, a new gear, and repitching the propeller. The first thing we have to do is change our engine model to be the 275 horsepower engine, which is also rated at 2,400 RPM. Here's our new engine curve, and we can proceed to the sizing where this data will automatically be used to increase the performance envelope of the propeller. We can evaluate both gear ratios also. Let's just start to see what PropExpert would find for an optimum gear ratio, and then we can choose the closest one, whether it's the PropExpert finds a gear ratio closer to 2 or 2.25. We'll see right here. So we're going to run our sizing. And what PropExpert finds is a relatively low reduction ratio of 1.6 is giving us 24.1 knots. So now what we would maybe, what we can glean for information from that is that the lower gear ratio may be more appropriate here. So let's set this to 2.0 and again see what our new pitch will be given the 275 horsepower available power. So now we're getting a pitch of 815 millimeters, which is a pretty significant pitch up from 640 that was initially specified by this propeller. So we may or may not be able to actually pitch up to this this new pitch, but we're getting 23.5 knots. We're still a little short on our performance goal of 26 knots. So we may, while this seems to be a pretty good solution to the problem, pitching the propeller up using the 2.0 gear ratio and the new engine, we still want to see if we can reach that 26 knot goal. So let's see if an entirely new propeller will allow us to get a little more speed. The vessel owner told us that they could actually swing a 610 millimeter propeller. So we'll enter that as our new maximum diameter. And we'll go back to the sizing page and allow all our propeller parameters to be sized. We'll stick with, we can size the gear ratio as well, and then we'll also decide what is the best gear ratio to use. So we're going to size all 4 of our parameters, and then we'll lock them down one by one. The first thing we see is that we're getting a relatively low gear ratio again, so we'll lock this down to the 2.0, and we'll rebuild this calculation. So now we're looking at a diameter of 610 millimeters, 782 pitch, and slightly more blade area. Again, we may not be able to get a propeller in this blade area, so let's just see how cutting it down to the 0.7 may affect this sizing. And it actually seemed to help out a little bit. So now we're looking at 24 knots with a new propeller, a new engine, and a new gear. It's still a little short of the performance goal, but as we saw in the vessel prediction here, there seems to be, for 26 knots, it just requires more power than is installed in the actual vessel. There are some things that we can do even after we've sized this propeller here to increase the top speed a little bit. So what else can we do? Well, one of the first things we could do is add cup to this new propeller in order to get a little more speed. So if we go in and add maybe like a gauge 5 or 6 cup, we might be able to get a little more speed. So we see that we pushed it up to 24.2 and cavitation changed from check to OK. If we view the details here, we see that everything looks pretty acceptable. There's no red here that's warning us of any sort of performance detriment, like with cavitation or with tip speed. BAR seems to be satisfied even with the 0.7, and overall everything looks very well behaved here. We can try increasing cup manually to see if we can get a little more speed out of this, but I really think that's about all we're going to get. So we'll stick with the gauge 5. So overall, in this webinar, we're at the end of the webinar now, and I just want to kind of summarize what we've done. Overall, we went through an initial sizing to recommend a propeller for this 14.5 meter motor yacht. We then used some actual sea trial data to anchor our prediction and improve the characterization of this specific hull compared to the average hull. What we found was that this particular hull was 6 to 7% less drag than our original prediction. Our original prediction had a multiplier of 0.9, which is the standard that PropExpert uses, and we found that a more appropriate multiplier of 0.855 was more appropriate. Once we had improved the characterization of our vessel's drag, we evaluated the new propulsion equipment options to reach a desired speed of 26 knots. Unfortunately, though, the desired speed was not achievable with the installed engine power, but we still have several recommendations to return to our client with. And they may be happy with 24.2 knots if they can, depending on how much money they want to spend swapping out propulsion equipment. There's a variety of suggestions we could have. For instance, they could easily achieve 20 knots with just a repitching. They could achieve around 22 knots with a new gear reduction and a new repitched propeller. But if they want to swap out the engine, the gear, and the propeller, we can actually push the boat up to 24.2 knots. And we're very confident in this sizing because we used prior trial to anchor the prediction down. I hope everyone has enjoyed this webinar. I really enjoy showing these off, and I enjoy working with our customers. I try to implement a lot of what I've learned from our customers into these webinars, and I hope that everyone finds them useful. If there's any questions, I'll take them now, and I'll do my best to answer them. For those of you who have to depart, thank you for attending. Please feel free to contact me by email or by phone with any additional questions you have. And don't let this be the end of our conversation. Let's continue this. And, I encourage everyone to start using the prior trial feature in all their sizings whenever they can get sea trial data from the customer. All right, thank you very much. And I'll open it up now to questions. We can use the chat window here, and I will do my best to repeat them and answer them.